Hello, welcome to Babil Math World. Today we are going to solve a problem relating to polynomial equation x to the power of 6 is equal to x minus 1 whole to the power of 6, and we have to find the solutions to this problem. So here we try to solve it. So here it is x to the power of 6 is equal to x minus 1 whole to the power of 6, bringing the right hand side to the left hand side. So x to the power of 6 minus x minus 1 whole to the power of 6 is equal to 0. So this one we can write x to the power of 6 as x cube whole square minus, in this similar way, x minus 1 whole cube whole to the power of 2 or square is equal to 0. And this is actually in the form of, if we think this is a square minus, if x minus 1 whole cubed is b, it is b square. So a square minus b square form we have got. So the identity is a square minus b square is equal to a plus b into a minus b. So using this algebraic identity, we can write the above equation as x cube, that is a plus b, x cube plus x minus 1 whole cubed multiplied by a minus b. So x cubed minus of x minus 1 whole cubed is equal to 0. So this we have got. So at this stage we can see that here it is the product of x cube plus 1 plus x minus 1 whole cube and x cube minus 1 of x minus 1 whole cube. It is just like, say, the product of two numbers m into n. M into n is equal to 0, say, implies m is equal to 0 or n is equal to 0. That means x cube plus x minus 1 whole cube is equal to 0, or x cube minus of x minus 1 whole cube is equal to 0. In order to solve it, first I take, let me call it denoted by equation 1. So now I take the first part of this one, that is x cube plus x minus 1 whole cube. I am considering only this. Consider x cube plus x minus 1 whole cube, and this x cube plus x minus 1 whole cube, if I let x is equal to a and x minus 1 is equal to b, then it comes in the form a cubed plus b cubed, and the expansion of a cubed plus b cubed is a plus b into a square minus ab plus b square. This one. So using this identity, suppose this is 0, say, as it is 0. So if it is 0, or even just I factorize it using this formula. So x cube plus x minus 1 whole cube, when we write using this right hand side, so then this becomes equals a plus b. Here a is x plus b is x minus 1, a plus b into a square, x square minus a is x, b is x minus 1 plus b square. B square here is x minus 1 whole square. So this implies x plus x is 2x minus 1 into, here we have x square minus x into x, x square minus x times minus 1 is plus x plus expanding this using a minus b whole square formula, x square minus 2x plus 1. This we have here. So that is 2x minus 1, x square with positive and negative sign we can cancel. Here we have one more x square minus x plus 1. So this is the simplification of x cubed plus x minus 1 whole cubed. And in the same way, the other product that is left with us is x cubed minus of x minus 1 whole cube. So that I take and I will try to factorize it in the same way. So here it is, x cubed minus of x minus 1 whole cubed. To expand it, so if we treat x is equal to a and x minus 1 is equal to b, it comes in the form a cubed minus b cubed. Its expansion is a minus b into a square plus ab plus b square. This is the expansion. So using this one, so if we treat x is equal to a and x minus 1 is equal to b, so the actual left hand side this is, and I try to write this in the form of this right hand side. So that becomes a minus b. A is x minus of x minus 1, it is a minus b, times a square plus ab plus b square. Still I have to write x square plus a is x, b is x minus 1 plus b square, that is x minus 1 whole square. So here x and x we can cancel, and this minus of minus 1 becomes plus 1. So this complete whole bracket, whatever is inside it, it becomes 1. So 1 into anything is one real number. So here we leave this first product and go to this second one, that is x square plus x into x square, x into minus 1 minus x, and at the same time expanding x minus 1 whole square using the form using the identity a minus b whole square, which gives x square minus 2x plus 1. So in this one we have x square, 3 terms. So 3x square and minus 2x minus x minus 3x plus 1. I added the like terms and I got this one. So this is equal to 3x square minus 3x plus 1 is actually this product, x cube minus x minus 1 whole cube. So this product x cube plus 1, x cubed plus x minus 1 whole cube we have here, it is 2x minus 1 into x square minus x plus 1. Substituting all this in equation 1, that is this is equation 1, substituting in equation 1. Substituting in equation 1. So equation 1 implies 2x minus 1 times x square minus x plus 1, and the second one is 3x square minus 3x plus 1 is equal to 0. So each product should be 0, or either one of them should be 0, either one of the product should be equal to 0. So if 2x minus 1 is equal to 0, then 2x is equal to 1 and x is equal to 1 by 2. Let me call it first solution. So x1 is equal to 1 by 2. Or the other possibilities, x square minus x plus 1 can be 0, or 3x square minus 3x plus 1 is equal to 0. So if this is 0, say x square minus x plus 1 is equal to 0. This is a quadratic equation. Comparing with the standard form of quadratic equation and comparing the coefficients, we get a is equal to 1, b is equal to minus 1, and c is equal to 1. So the solution is x is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. So x is equal to minus b, so minus of minus 1 plus 1 square root of b square minus 1 square is 1 minus 4 times 1 into 1 divided by 2 into a, 2 into 1, 2. So here we have x is equal to 1 plus or minus 1 minus 4. 1 minus 4 is root minus 3. So square root of minus 3 divided by 2. So the other solutions we get here, right, x2 is equal to 1 plus root minus 3 is root 3i by 2. With plus sign I take one root, and by minus sign 1 minus root 3i by 2, we get one more root. So here one more equation is present, 3x square minus 3x plus 1 is equal to 0. We solve this equation and we get two more roots for that. So here again comparing with the standard form of the quadratic equation, a is equal to 3, b is equal to minus 3, and c is equal to 1. Using the same formula to solve the quadratic equation to find the roots. So here we get minus b. So minus b is minus of minus 3 plus or minus square root of b square minus 3 square minus 4 into 3 into 1 divided by 2 into 3. So x is equal to minus of minus 3 is plus 3 plus or minus square root of 3 square is 9 minus 4 into 3 into 1, 12 by 6. So x is equal to 3 plus or minus 9 minus 12 is minus 3 root minus 3 divided by 6. So the other two solutions which we get are x4, I write x4 is equal to 3 plus, this is root 3i by 6, and one more solution is x5 is equal to 3 minus root 3i divided by 6. These are the 5 solutions we have got here. So here we may have a doubt that actually we have a 6th degree polynomial equation, so we should get 6 roots. But actually when we expand it, x minus 1 whole to the power of 6 using binomial expansion, so the first term we get here is x to the power of 6. That means in this way. So x to the power of 6 is equal to, so x to the power of 6, and some other terms we get alternatively positive and negative terms, and the power of x gradually decreases, x to the power of 5, x to the power of 4 in this. So this x to the power of 6 and x to the power of 6 cancels, and we will actually get a 5th degree polynomial equation equated to 0. So not sixth degree, because sixth the power, x to the power of 6 and x to the power of 6 is cancelled. So it is only a fifth degree polynomial equation. So it has 5 roots, and we have got all the 5 roots. So the 5 roots are given by x1 is equal to 1 by 2, and x2 is equal to 1 plus root 3I by 2, and x3 is equal to 1 minus root 3I by 2, and the other two roots are x4 is equal to 3 plus root 3I by 6, and x5 is equal to 3 minus root 3I by 6. These are the 5 roots of this very interesting given polynomial equation. I think you like this solution. So if you like this video, please subscribe to my channel. Thank you for watching.